A snowstorm in cold, dark climates can allow for snow to stick and build up in a given field. So I'm from Vermont. This is definitely true. The winters are cold and they're dark, and that allows for the snow to just keep piling and piling up because there's not sun for long enough and hot enough to even melt it during the day most times. Precise predictions are tough, but the level of snow on a snow piled up in centimeters X hours after 4 p.m. So we're assuming it's dark at 4, and that's pretty true in the winter. And we have this continuous snowfall here that's going to tell us how built up it is in centimeters at X hours after it's gotten dark at 4 p.m. and it continues to snow. So writing our units off to the side, how I like to at the beginning, we have L of X, that must stand for the level of snow after X hours. We're going to have L prime of X and L double prime of X. So if L of X is in centimeters after X hours, then the first derivative is going to be in centimeters per hour. And then the second derivative is going to be in centimeters per hour squared, or because we're interpreting this, I would say in centimeters per hour each hour. What's happening to it? So I think what's helpful with these problems is to just think about real life. So we had a patient's temperature changing, and we know that fever is reduced after medicine, but then medicine doesn't work forever, so that reduction slows down. This one, we're talking about snow on the ground, and if it continues to snow all night long and it's dark and snowing, I think the snow is going to keep going up, and it's going to go up increasingly faster. So that would be my guess, is that these first derivative is probably going to be positive because the amount of snow is probably increasing. And then the acceleration of the snow, that second derivative, I would say it's probably speeding up and getting more and more snow faster and faster. And this is why I moved away from the north. But let's look. We have L of 10 to find first and interpret our results. So we're just plugging into the original. I'd grab my calculator. I have 0.02 times 10 cubed minus 0.06 times 10 squared plus 6 times 10. I would encourage you to grab your calculator and see what you get if you haven't been plugging in this section, because I want to make sure you can get it before the homework. So you have 0.02 parentheses 10 cubed minus 0.06 times 10 squared plus 6 times 10. And I am getting 74. So that 74 stands for 74 centimeters. And so we could say after 10 hours, this is not just 10 hours, it's 10 hours after 4 p.m. So we could say after 10 hours, after 4 p.m. of snowing, there are 74 centimeters of snow in the field. I don't necessarily like wording it like that. That first part could be a bit more concise. So let's think about what time is 10 hours after 4 p.m. So 1 hour is 5 p.m. You can count on your fingers here with me. 2 hours is 6, 3 is 7, 4 hours later is 8, 9 p.m. is 5 hours later, 10, 11, 12, 1, 2 in the morning would be the time. At 2 a.m., the level of snow, or the snow, is at 74 centimeters. Either are totally fine. I just think it looks a little weird to say after 10 hours, after 4 p.m. because not just 10 hours, because it can't be during the day. It has to be when it's dark for this to work, so that the sun isn't melting it down. The next part says to find L prime of 10. So the first thing we want to do is just figure out what L prime is. So we need to bring down our power, subtract 1 for the new power on this, and then we will plug in what we get for 10. So the derivative, L prime of x, is going to be 0.06. 0.02 times 3 is 0.06. X squared minus, we have 0.06 times 2, which is going to be 0.12. X plus the derivative of 6x is 6. So we just need to take the derivative of L, call it L prime, and then we're going to plug in L prime of 10. I, again, would suspect this is going to be a positive derivative because I think the snow is going to be increasing. So we can kind of think about that as we plug in 0.06 times 10 squared minus 0.12 times 10 plus 6. And we get 10.8. And it's a derivative, so it has 2 units, centimeters per hour. And that makes sense to me. It's dark and it's snowing, so the snow is just going to be increasing. So we plugged in 10 hours. I'm just going to use the concise way. So at 2 a.m., the snow levels will be, we could say increasing, maybe I could say rising, some sort of word to note that it's positive, rising by 10.8 centimeters per hour. So the snow levels are still rising up at 2 a.m. because it's continued to snow and it's continued to stay dark. So we can compare that to the second derivative. One thing I want to think about is I would assume these have the same sign because I assume the amount of snow sitting there is going to be speeding up more and more. It's just gaining momentum because it's dark and it's still snowing. I think it's nice to have a prediction because it's real life problems so you can see if your answer seems right or not, but you obviously don't have to. But what we do need to do is take the derivative. So I'm going to bring down the power. 0.6 times 2 is going to be 0.12 x, and then negative 0.12 is the derivative of negative 0.12x, and the derivative of 6 is 0. So I can grab my calculator and plug in 10 to this. So we have a positive 0.12 times 10 minus 0.12. And I'm getting 1.08. It's the second derivative, so it's going to have centimeters, and then it's going to have 2 units in the denominator, centimeters per hour squared, or centimeters per hour each hour. So we want to interpret this. The first thing that we're going to have to say is about the first derivative. So kind of back to what we talked about in the last example, we said something is dropping. This one's not dropping when we talk about it. This one's rising. So we're going to talk about the first derivative first. We'll say the rise in the snow level will be, we could say, rising, or we could talk about speeding up versus slowing down on this one. So they're both the same sign. This is positive and this is positive. So same sign for L prime and L double prime. Does that mean the amount of snow is speeding up or slowing down? Same sign means speeding up. Even if they're both negative, it means speeding up. Like we talked about with the stone. They were both negative, and that's when the stone was speeding up. Here they're both positive. So the rise in the snow level will be speeding up or we could say the rise in the snow level will be increasing. We could interpret it like the temperature one. There's a few ways to do it, but just showing you the other way you might have to interpret in WebAssign, I would say the rise in the snow level will be speeding up by this amount above 1.08 centimeters per per hour each hour. And that kind of goes back to what I was guessing, having grown up in snow. I thought we were going to get 2 positive answers and it would just keep growing more and more. So definitely the hardest part is the interpretation, but just take these slow. The derivatives aren't too bad in this section, so don't let this section intimidate you. You can definitely take a derivative, you can definitely plug in, and then the interpretation will come the more you do it.